Hello, very good evening, guys. Welcome to BYJU'S exam prep. Very good evening, all of you. I hope everyone is good, fine. So before starting the session, please do let me know everything is good and perfect with audio and video. Good evening, very good evening. Okay, so in this session, we will be discussing the 5 years of previous year question of a very important and the conceptual subject, that is engineering mechanics, starting from 2019 till this year, that is 2023. Why this is an important? Because for the students those who are targeting 2024, you have to have a complete understanding of the previous year question, at least 5 years. In every session, I always tell my students, first of all, concentrate on the first 5 years, then go for the next 10 years of problem. Okay, because once you are seeing the latest trend of every subject, you'll be having a better understanding what is the level of questions they are expecting, what the question they are framing, and what should be your preparation towards cracking the GATE examination. Okay, so very good evening, all of you. I hope everyone is good, perfect, and eagerly waiting. Every alternate days we have planned the complete 5 years. So today's session also will be having the slightly lengthy problems. The number of questions are slightly on the higher side. So might be we can go beyond 1.5 hours or till 2 hours. Max to max 2 hours will be the length of this session. Okay. So very good evening. Good evening. Now, I hope so everyone has connected with me on my Telegram channel, that is Mechanical by Suraj. And also you can drop me a mail at suraj.s9@byju's.com, because students do have difficulty during their preparation journey, right? And always we are ready to help you out in any stage. That could be technical aspects, that could be non-technical aspects. Students, they are preparing for GATE examination, but what happens during the preparation journey, they are getting demotivated, right? So you can drop me a mail and we can have a discussion, or you can directly text me on my Telegram channel also. Okay, fine. Chalo. This is a very important update for all the mechanical and civil students. Already civil versus mechanical war has been started. I think at 5 o'clock Chandra sir has taken the fluid mechanics subject, and the top 5 students will be getting the surprise gift hamper. So make sure it's a combination of YouTube and app series. So make sure you are getting the benefit of this. Okay, so this is an important update. So let's proceed to the next update for all of the students. If you're planning to give GATE examination 2024 national scholarship test, we have planned on 18 June exactly at 12 p.m. I always do tell you, whenever you are attending these kind, or whenever you have attempting these kinds of tests or the full length mock test, you will be getting an insight what should be your preparation strategy or where you are lacking behind. And if you are getting a good result, there's a good, we can say, scholarship waiting for you. Fine, right? Chaliye. So now let's begin the session. Before that, Rakesh sir will be coming up live on 20th of June 7:30 and talking about what should be your strategy to ace in GATE in the next 8 months. What should be your preparation? What should be your step-by-step or monthly plan you should be having? Okay, fine. Chalo. So now let's start the problems of 2019 to 2023. I've taken the questions topic wise also, like some questions will be topic wise till 2021 and 2022, 2023, because these are the recent years. So I've taken collectively at the end. Okay, fine. Right. Chaliye. Okay. Okay, perfect. Can we proceed? The first question on the screen is this. Fine. A circular disc of radius r is confirmed to roll without slipping at P and Q as shown in the figure. If the plates have velocities as shown in the figure, the magnitude of the angular velocity of the disc is positive. What is the magnitude of the disc? Now it's a very easy question. We are having a disc, circular disc. At the upper side, it's a tangential velocity of v. The lower side, we're having a tangential velocity of 2v. You have to tell me what is the angular velocity of this circular disc. Very easy question. You can apply the concept of eye center and get the answer. Yes, anyone? What should be the magnitude of the angular velocity of the disc is? Let us remove this positive. Okay, so if you try to apply a simple eye center approach, because eye center will be helping us to get the answer very quickly. Now, if you see the top portion, if this would have been the equal velocities, let's say P and Q, if we're having V and V, so the eye center will be exactly at the center point. That eye center will be exactly at the center point, right? But as the top and the bottom points are not having equal velocity, so let us draw the velocity profile and let's see what is the possibility of getting the correct answer, right? So we are having this as velocity V. This is your velocity VP, V. This is point P, right? We'll be having a straight line. Okay. Now, the velocity at the bottom is 2V. It is twice of V. So, if you draw, definitely your eye center will be somewhere above this. Let's say this is center O. It will be at a distance, some X distance above the center, right? Let us suppose this is, I'm taking from this point as X, right? From this point to this point is X. Okay, I'm taking from this point till eye center, this is distance X, and the rest will be 2r minus X. Okay, right? So now I can simply say, because this is a rigid disk, this is the single body, so I can simply say that the velocity at point P is equal to the distance from the eye center, that is Pi into angular velocity. Yes. And also we can say what is Pi, that is equal to X. So this is X into omega, that is Vp, right? That is equal to V. And similarly we can say this is velocity at point Q is 2V. So velocity at point Q is 2V, that is equal to, this is your point Q. So Qi into omega. What is Qi? Qi, this will be 2r minus X, 2r minus X into omega, and VQ is twice of V. If you take these two ratios, this V will be cancelling out and you will be getting the value of X. You will be getting the value of X. So let us take the ratio. It is V by 2V is equal to X into omega divided by 2R minus X. Let us find out where this X will be located. Okay. So I can say this will be 2R minus X is equal to 2X. So here we can say X is equal to 2 by 3, 2R by 3. Okay, 2R by 3, right? So we got the value of the eye center from the top portion. Top portion से eye center का value पता. Now it's a very easy question. If ऊपर वाला plate और नीचे वाला plate के if it having the same velocity, right, then the eye center will be exactly at the center point. But क्योंकि top positions and the bottom points are not having equal velocity, that is the reason the eye center has been shifted from the center position. Okay, so we got this X value, so we can simply say V is equal to X into omega. So omega is equal to V by X. So this is 3V by 2R. 3V by 2R is the angular velocity of this particular rod. 3V by 2R. Option C is the correct answer. Okay, option C is the correct answer. Is this clear? A simple question from the concept of your eye center. Okay, good evening, yes, everyone, please do let me know everything is good and perfect with audio and video. The students are joining right now also. Chaliye, second question on the screen. An attempt is made to pull a roller of weight W over a curb that is stepped by applying a horizontal force F as shown in the figure. The coefficient of the static friction between the roller and the ground, including the edge of the step, is mu. Identify the correct free body diagram of the roller when the roller is just about to climb over the step. So you have to identify, there are 4 diagrams being given. What will be the correct free body diagram? Now here it is clearly stated that it is about to climb. Okay, it is said that the roller is just about to climb. That means we can apply the static equilibrium. We can apply the condition of static equilibrium, right? So which one will be giving us the correct representation of the free body diagram? Option A, option B, option C, or option D? Anyone? Simple question. A, B, C, or D. Now it is clearly mentioned that it is at the static equilibrium. So definitely can we say that at the hinge point, we'll be having this reaction force. Okay, there's a reaction force R and there's a weight W acting. So there are 3 forces acting. So simply we can say option C is the correct answer. the reaction force, the applied force F, and the weight W is the correct representation of this particular. Okay, fine. We'll be having not reaction, we get a normal reaction at this particular H, which will be passing through the center. Because this body is about to climb, we can say this is a condition of static equilibrium. Is this clear? Understood? Okay, the correct representation is option C is the correct answer. Okay, you'll be saying, sir, option A bhi to sahi jaisa lag raha hai. Can we say like this? No, it is not like this, right? In option C, it is whenever we are drawing the free body diagram, we are never ever drawing the surface. We always draw the body and what are the forces acting on the body. That's it. Okay, fine. If I want to draw the free body, we remove all the other bodies, we only draw that body and show how many forces are acting on that body. Okay, so option C is the correct answer. Let us prove the next question. A beam of negligible mass is hinged at a support P and has a roller support at point Q. A point load of 1200 Newton is applied at point R. So there is a force of 1200 Newton applied at this point. What is the magnitude of the reaction force at point Q? So you have to calculate. Let us say this is the reaction force RQ. The roller support, this is the reaction force. This is a 1 marks question. Okay, so tell me quickly, what will be the reaction force RQ? Anyone? Yes? What will be the reaction force RQ? Now we need to calculate the RQ. Now if you take the moment about point P, if you take moment about point P and make it equal to 0, because this entire body is in equilibrium, right? We can get the value of this. So what is this distance? That is 12. So 1200 into 5. Okay, RQ, what is this height? That is equal to 4. This is clockwise, this is anti-clockwise, this is RQ into 4. So from here, the reaction at point Q is coming out to be, this is 1500 Newton. Are we getting this 1500? 1 marks question. 1 marks question. Okay, so the reaction at point Q is 1500 Newton. Simple question asked in 2020. Okay, clear hai? Everyone, please do let me know. All good. Okay, so let's proceed for the next question on the screen, question number 4, because there are many questions, so we need to cover up. Two smooth identical spheres, each of radius 125 mm and weight 100 Newton, rest on a horizontal channel having vertical walls. The distance between the vertical walls of the channel is 400 mm. The distance be given as 400. The reaction at the point of the contact between the two spheres. So we have to calculate what is the magnitude of the reaction force at the point of contact. दो जो spheres है उसके बीच में जो reaction होगा, yeah, that we have to calculate. So what we have to do, we have to draw the free body diagram, right? So on, let's say this is sphere 1, this is sphere 2. This will be the weight W, right? This is, let us say, R2. Let's say this is R1. Right? Fine. This is W and this is R3. So we need to calculate this magnitude of R1. We need to calculate the R1, the reaction between the two cylinders, okay, or the spheres, not cylinders. The reaction at the point of contact between the two spheres we have to calculate. That means we have to calculate the value of R1. कैसे करेंगे भाई? Simple, free body diagram, Lang's theorem apply कीजिए and get the answer. Okay, चलिए, let's try this. Let's try this. Now, if I draw the free body, let's say this is sphere A, this is sphere B. If I draw the free body diagram of sphere A. So, if I draw the free body diagram of sphere A, so there is a weight W acting downward. There's a weight W acting downward. There's a reaction force R2. And there's a reaction force R1 acting. But the thing is, I need to calculate the this one angle also. So for calculating this angle, can we say, let us suppose this, I'm taking this triangle, let us say this is theta, right? So that means it is making an angle of theta with the horizontal, this is R1. Right. So this distance is 400, this total distance is 125 plus 125, that is 250. So I can say cos theta is equal to, we can say 400 by, this one will be 25 plus, this one will be 400 divided by, what will be the total distance? what will the total distance over here? Now this is 125, this one also 125, so total distance will be 400 minus 250. 400 minus 250 will be the base, and the hypotenuse is 250. Okay, yes, are we getting this? Cos theta is equal to 400 minus 250 divided by 250. So 400 minus 250 is somewhere around 150. So cos theta is equal to 150 by 250, that is equal to 3 by 5. That is equal to 3 by 5. Okay, so I got the value of cos theta is equal to 3 by 5. Right? If cos theta is equal to 3 by 5, so I can say sin theta will be equal to 4 by 5. Simple. I can say sin theta will be equal to 4 by 5. Right? Now I can say all the vertical force equal to 0. So R1 sin theta is equal to weight of this block. What is the weight of this block or this particular sphere? It is 100 Newton. Each is having identical sphere. So I can say R1 will be equal to 100 divided by sin theta is 4 into 5. So this is 25, 125 Newton. Are we getting this? 125 Newton, everyone? 125 Newton is the final correct answer. So 125 Newton is the final correct answer. Okay, that means the reaction between at the point of contact between the two spheres is equal to 125 Newton, and they have told to round off to 1 decimal because but we are getting in integer, so perfect. Right? Clear? Proceed. Let us proceed to the next question. Question number 5th on the screen. Okay. Now, many times you are getting a questions, very easy question from the trusses. This is one of the easiest question. The figure shows an idealized plane truss if a horizontal force of 300 Newton is applied at point A. So we are applying a horizontal force of 300 Newton at point A. What is the magnitude of the force produced in the member CD? You have to calculate the force in this member. Quickly, what will be the value? What will be the value? Anyone? This is a question which was asked in 2020 GATE for 1 marks. Anyone? Now, whenever you're getting a question of trusses, the very important concept that you have to remember is identify any point or any joint where 3 forces are acting. Okay, if you visualize at point B there are 3 forces are acting, 2 collinear force. If I say this is point B, this is your FAB, this is your FBD, right, and this is FBC. And already I have told in number of sessions, whenever we are having a joint where 3 forces are acting, out of 3 forces, 2 forces are collinear, then the third non-collinear force will always be equal to 0. That means over here BC is a 0 force member. So if BC equal to 0 force member, again try to come at point C. Now if I take at point C, AC and CE are collinear, so CD is a 0 force member. Okay, so the answer for this is 0. The answer for this is 0. Is this clear, everyone? Simple question, a simple question. Okay, chalo, let's see. Next question on the screen. Done? Anyone having any doubt in this? All clear? The 0 Newton, and moreover, if you try to extend, I can say how many 0 force members are there? The 0 force members. The 0 force members. We are having BC, we are having CD, DE also 0 force member, and EF is also 0. So there are 4 members which are 0 force. This is a, we can say, slightly extension to the discussion of this problem. Okay, so this NAT problem, very easy question. Its member in the force in the member CD is 0. Clear hai? This 0 is being too much bold, I think. Dark ho gaya jada. Okay, chaliye next question. Question number 6 on the screen. The members carrying 0 force in a truss shown in the figure for any load P greater than 0 with a non-appreciable deformation of the truss. That means there's a rigid truss, there is no deformation happening. What will be, how many members are having 0 force? How many members are having 0 force? Are you able to see the diagram appropriately? I've just magnified this so that you can able to see this easily. Now, how we can identify the zero force member? Identify that joint where we are having three members. Point D is having three members. CD and DE are collinear, so HD is or DH is a zero force member. If I talk about joint G, GF and GH are collinear, so GC is a zero force member. If I take point B, AB and BC are collinear, so BF is a zero force member. So at this point of time, we can say HD, GC and BF, these are the zero force member. Now, if you try to concentrate on joint E is, now this height and base is 45, so this is also 45. If you see, the height of this truss is 1 meter, this DE length is 1 meter, so the angle made by the member HE with DE is 45, and this support is also making an angle of 45. So can we say the reaction, this is a roller support, so single reaction, so the reaction at point E will be along the HE line, yes. Okay, so I can simply say if all the reaction force will be going towards HE, so I can simply say DE will be a zero force member. If DE is a zero force member, DE is equal to CD, this is also zero force member. Okay, fine. Is this clear? So now we are having to the list DE and CD being added to the zero force members. What about the other members? Okay, you'll be saying, sir, can we go for GF and GH? If you talk about GF and GH, these are not zero force. These both are equal, but these are not zero force member. Because GF, why it is not zero? If you take joint A, AB is a non-zero, AF is a non-zero. If AF is non-zero, definitely FC and GF will be non-zero. And at point C, this is non-zero. So we can say this is also non-zero. Okay, so in total, we are having 5 members as zero force member: HD, GC, BF, DE, and CD. That is option C. That is option C. Okay, clear hai? Option C is the correct answer. आराम से करेंगे. There is no hurry. I want you guys to fully concentrate on this. कहीं भी doubt आएगा, we'll be going for that. चलिए, next question, question number 7. A plane truss PQRS where PQ and QR are having equal length and PQR is making an angle of 90 degree as shown in the figure. The force in the member PR and RS respectively are. What will be the magnitude of the force in the members of PR and RS respectively? Can you tell me what will be the answer? Quickly. Are you able to see this diagram? Let me hide myself. Quickly, what will be the force in the members PR and RS respectively? Simple question. है ना? Yes, a simple question. Now, whenever you are getting a question from the trusses like this, there are two methods that we can apply. Either we can go for method of joint or we can go for method of section, right? Now, whenever you are having intermediate any forces are acting, go for method of section. Best way. Easily we will be able to solve the question. Right? So if you go for method of section, now okay, very good, Surya. Now the challenge is, sir, where we have to cut the section. Before cutting the section, if you concentrate at point Q, now Q point pe only two forces are acting, no applied load, and both forces are perpendicular. Can we say these two are zero force members? Can we say these two forces, that is PQ and QR, are zero force? Right? And if these are zero force, now we can take the section like this and remove the bottom position. We can take the section like this and remove the bottom positions, right? Section like this and remove the bottom position. So I can say there's a force F PQ, which is basically equal to 0. This is a complete member, right? This is R, this is F PR, and this is F RS. In the question they are asking PR and RS. Okay, both they are asking. 45, 45, this is 45 degree. Applied load of F. Okay, fine. So now we can say that the total horizontal force equal to 0. So I can say FPR cos 45 is equal to F. So from here FPR is equal to 1 upon root 2. This is F root 2. Positive means it's a tensile force. It's a tensile force. Okay, so F root 2. So option B and option C eliminated. Now we are left out with option A and D. Now I can take all the vertical force equal to 0, vertical force equal to 0, FPQ already 0, already we have seen that's a 0 force member. So I can say FPR sine 45 plus FRS equal to 0. So from here, the force in the RS member is equal to minus of FPR sine of 45. Okay, PR is 1 upon root 2, that is minus F root 2 into 1 upon root 2, that is minus F, that means F compressive in nature. Minus means compressive. Okay, fine. So RS is minus F compressive. Option D is the correct answer. Right. So forces in the member PR is F root 2 tensile and a force in the member of RS is F compressive, because we got a negative sign. Clear है? Done? Yes. Anyone having any doubt? बहुत easy questions हैं. चलो. Now let's proceed. देखो, mechanics is a subject. If you know the concept, you will never ever have any difficulty. है ना? अगर आपके concept strong है, no problem with that. Right? Okay. Fine. और अगर आप concept strong नहीं है, then it is very difficult subject. चलिए. Next question. Question number 8 on the screen. A block, अरे बहुत easy question है. ये तो आप लोग, you can tell me within a fraction of 10 seconds, I think. A block of mass 10 kg rests on a horizontal force. The acceleration due to gravity is 9.81 meter per second square. The coefficient of static friction on between the floor and the block is 0.2. That means mu value they are given as 0.2. Right? A horizontal force of 10 Newton is applied on the block. What is the magnitude of the friction force on the block? What is the magnitude of this friction force? Definitely this is the direction of friction force, right? This is the weight, that is 10g, and this is your normal reaction. Okay, quickly, what will be the magnitude of the friction force? So first of all, let us try to understand, are we talking about a static condition or are we talking about a dynamic condition? For that, let us calculate the limiting value. Limiting friction, that is equal to mu into n. Okay, so mu is 0.2, n is 10g, so that is equal to, you can take it as 9.81, so this will be how much? 19 point, this will be 2 into 9.81, that is 19.62 Newton. 19.62 Newton. So in order to move this block, you need to apply 19.62 Newton. You are applying only 10 Newton force, so definitely we are talking about a static condition. So at that point, the applied force will be equal to friction force. The answer is 10 Newton. Okay, clear? Eh? Yes, because we know that if you try to draw the diagram, that graph between the applied force and the friction force and the applied force, this is the limiting point, right? This is the limiting point and this is the dynamic. Okay, dynamic, right? We are talking about this point 10 Newton, applied friction is also 10 Newton. Okay, question number 8 done. Question number 9 on the screen. A very easy question. A block of negligible mass rests on a surface that is inclined at 30 degrees to the horizontal. When a vertical force of 900 Newton and horizontal force of 70 Newton is applied, make sure the block is having negligible mass. What should be the coefficient of static friction between the block and the surface? Very easy question. Apply and tell me what is the answer. I think you are not able to see. 1 second. Yeah. I hope so now it is visible. The diagram is visible. I'm giving you a minute to try and solve it quickly. Quickly, what is the value of this coefficient of static friction? अरे बहुत easy question है guys. चलिए, let's try this. Now let us draw the FBD, है ना? Let us draw the FBD. this will be the normal reaction, and this will be the normal reaction, something like this, the normal reaction, right? Now tell me one thing, 0.83, okay, anyone else who has solved this? One second guys, anyone else who has solved this question? Yes, 0.83, anyone else who has given me? Chaliye, let's try this question, but easy hai. Now first of all tell me what will be the direction of friction. देखो block is not having any mass, block का कोई mass नहीं है, right? Only the upright force is acting. Fine. So tell me what will be the direction of friction. तो उसके लिए we have to see what is the magnitude of these forces, right? So let us resolve this along the inclination. This will be 750. This is 30. This is 30. 750 cos 30, right? And downward will be 750 sin 30, right? Similarly, we are having 900 along this direction. This is 900. Now this is 30. So what will be this value? This is your somewhere around. This is 30. This angle will be 30. This is also 30. So this is sin 30. Okay, sin 30, and this one is downward direction, 900 cos 30. Okay, so I have resolved all the forces. So tell me, by seeing the magnitude of these two forces, what will be the direction of friction? Quickly. चलिए बताइए. Now if you see 900 sin 30 is 450 Newton, somewhere around 450. 700 cos 30, let's try to find out what's the value of this 750 cos of 30. So this is 649. That means the net force is in the upward direction. If net force upward, that means the direction of friction will be downward. This with the direction of friction. Okay, is this clear? देखो यहाँ पे mistake कहाँ होता है identifying the direction of friction. By sin 30 is 1/2, 450 Newton force downward, down inclination. Sin 50 cos 30 somewhere around 650 Newton, which is upward. So definitely there's a total force acting in the upward direction. So the opposite to the direction of motion will be the friction force. So up you can easily calculate. So I can say the normal reaction will be equal to 900 cos 30 plus 750 sin 30. Okay, fine. So from here let us calculate what is this value. 900 cos 30 plus 750 sin 30. Okay, so this is coming out to be 1154.42 Newton, right? Now if I talk about the frictional force, because F is equal to mu into N, we have to calculate the value of mu. So I can say that friction force will be equal to 750 cos 30 minus 900 sin 30. Let's calculate this magnitude. 750 cos 30 minus 450, that is coming out to be 200, somewhere around 200. 199 means 200. 199.52 Newton. Okay, so F is equal to mu into N. Mu is equal to F by N. Just we have to place it. 199.52 divided by 1154.42, somewhere around, what's the value? 1154.42. It is 0.1728, round off to 3 decimal, 0.173 is the final correct answer. 0.173 is the final correct answer. Okay, so the answer is 0.17. The answer is 0.17. Is this clear? Anyone having any doubts? Surya, is this clear? 0.17. ठीक है, 2 decimal तक बोला, 0.173 is the correct answer. 0.17 we can mark it. चलिए next question, question number 10 on the screen. A 2 kg block shown in the figure, top view rests on a smooth horizontal surface, is attached to a massless elastic cord that has a stiffness of 5 Newton per meter. The cord is hinged at point O. I hope so you are able to see the diagram. This is your hinge point, that is O, right? Hinge is initially unstretched, always remains elastic. The block is given a velocity of 1.5 meter per second perpendicular to the cord. This is the velocity that we are providing. Okay, the magnitude of the velocity, in meter per second of the block at the instant when the cord is stretched by 0.4 meter. Simple question. Here we have to apply the conservation of energy. Kyunki whatever kinetic energy we are providing, that is converted into your potential energy, that is we are expanding that, we are stretching that particular cord by a distance of 0.4 meters. So we can apply the concept of conservation of energy and solve it, and let's see what is the answer. Okay, so applying the conservation of energy, applying energy conservation, whatever is the total kinetic energy. If I take this as the total kinetic energy plus the total potential energy is exactly equal to the total kinetic energy plus the total potential energy, right? So this is half into m into v square is equal to half into k into x square. Okay, just 1 second. And we are having this is initial velocity. This initial velocity is 1.5. Half into m into v final square plus half into k into x square, right? So half get cancelled और mass is कितना है? Mass is 2 kg. 2 into 1.5 square is equal to 2 into final velocity is we have to calculate, plus k is how much? 5. Unstretched is 0.4 square. Okay, solve it and tell me what is the value of the final velocity. Okay, so we can say this is final velocity square is equal to 2 into 1.5 square minus 5 into 0.4 square. Okay, what is the value of final velocity that we are they are asking? A 2 marks question from the concept of kinetics. We are getting this as 1.36 meter per second. Please check, are we getting this? Let us cross verify. 1.5 square into 2 minus 5 into 0.4 square under root of this 1.52. Yes, or 1.92, near about to this 1.36. Option A, are we getting? Oh, 1 second. 1 second, because we have to take that 2 also, na? We have to take that 2 also. कितना है? 1.5 square into 2 minus 5 into 0.4 square divided by 2, root of answer, that is 1.360 meter per second. This much is the value, right? So I think that is option A is the correct answer. Option A is the correct answer. Okay, fine, clear hai? Option A is the correct answer. Simple, we have to apply the energy conservation and get the final result. Chaliye, very good. Next question on the screen, question 11. Arey, bahut easy. This is also when I was the easy question. The wheels and the axle system lying on a rough surface. Rough means there's a friction we need to take into consideration. So there is a wheel and an axle. So 2 wheels are connected, and in between it is an axle. There's an axle, right? So question is, each wheel has a diameter of 0.8 meter and a mass of 1 kg. Assume that the mass of the wheel is concentrated at rim. That means we are talking about the wheel is a rim type. Neglect the mass of the spokes. Diameter of the axle is 0.2 and its mass is 1.5 kg. Okay, diameter of the axle, axle is having a mass of 1.5 kg and diameter of 0.2. Neglect the moment of inertia of the axle. Assume G is equal to 9.8. The effort of 10 Newton is applied on the axle in the horizontal direction as shown in the midspan. Okay, this effort is applied. Assume that the wheels move on horizontal surface without slip. What is the acceleration of the axle system in horizontal direction? Simple question. It's a very easy question. If you try to visualize, the mass of the wheel is 1 kg. Okay, so there are two wheels being connected, so the total mass or mass of the wheel is, mass of wheel will be equal to 2 into 1, that is 2 kgs, and the mass of the axle is equal to 1.5 kg. So can we say the total mass of the system will be equal to 2 plus 1.5, that is 3.5 kg. If I take the entire system to be a single system, so we are having a total of 3.5 kg, right? So now we can apply the simple concept. Now this is the direction. If I say this is the direction, okay, so definitely the friction will be in this direction. This is the direction of friction. So I can simply say that, one second. This is the direction of friction, not opposite. This is the direction of friction. Okay. Now there are two wheels. So can we say that the total force acting on this body is equal to mass into acceleration? Now what's the total force? 10 Newton is the force acting in the horizontal direction, minus. Now there are two wheels. A friction force created over here, friction force created over here, that is minus 2F is equal to mass is 3.5 into A. 3.5 into A. Right. So 10 minus 2F is equal to 3.5. A can I write as R into alpha. Right. What is the radius? Diameter is 0.8, radius will be 0.4. So 3.5 into 0.4 into alpha, 10 minus 2F. So after this, we are getting one equation. 10 minus 2F is equal to 3.5 minus 3.5 into 4. This is 2, 14, 1.4, 1.4 alpha. Let us say this is equation number 1. Alpha is an angular acceleration. Okay. Now, if you try to apply now moment, your torque equation, right? If you try to apply the torque equation, this is the frictional force. This is the frictional force, right? And this is the force acting, 10 Newton force. This is 0.1 meter. I think 0.1 meter only. Yeah. 0.2 meter is the axle. 0.1 meter. So I can say the total torque acting is equal to I into alpha. What's the total torque acting? This is the direction of motion. So I can say this is equal to your 10 will be creating an anti-clockwise movement. So this is minus 10 into 0.1 plus F into radius is 0.4. That is equal to I into alpha. I is, this is a disc. Right, this is a we can say, oh, so this is a rim. They have already stated this is a rim. So we can say mr square, mr square. Because there are two wheels, we can say 2 into mr square into alpha. So this will be minus 1 plus 0.4 f is equal to 2 into mass is 1 kg, radius is 0.4 square into alpha. So this is equal to 0.4 f minus 1 equal to 0.16, 0.32 alpha. Equation number 2. Okay, equation number 2. So we are having two equations. Can we solve these two equations, get the value of f and alpha? This is equation number 1, this is equation number 2. Solving these two equations, we are getting the value of friction is equal to 2.61 Newton, right? And the angular acceleration is coming out to be, when you place this value over here, 3.409. Yes, John Philip, 3.409 radian per second square. Okay, fine. So we got the value of friction, we got the value of alpha. Question is, what is the acceleration of the axle? So that in the horizontal direction, that means what is the action of the center of mass? That is equal to R into alpha. R is 0.4. Alpha is 3.409. Let's calculate and tell me what's the answer. Till then, let me clarify the doubt of John Philip. 13.1.3636 meter per second square. Are we getting this? Sir, how old NIT, Trichy, Surathkal and Warangal compared to new IITs like BHU? Now, if you see the latest, if you see the NIRF ranking, you will be getting a complete clarity. If you have seen, there's a government has released an NIRF ranking 2 weeks back, and you can see research-based ranking, overall institute ranking, your different categories are there. So based on that, you can get a clear-cut idea. If you want to see a research-oriented institute, you can categorize, you can sort it down according to the research, right? If you want to In that case, you can definitely go for NIT Trichy is the topmost. I can rather say Trichy, Surathkal, and Warangal. These three are the top NITs, much better than the new IITs. Much better than new IITs. Okay, fine. In terms of placement only, I'm saying, I'm not talking about research based. Research based also is good, but in terms of placement, these are much more better than that of the new IITs. Okay, fine. But last 2 years, the trend is slightly shifting. Some new IITs have done marvelous work, so their ranking has been improved in a great way. So definitely what happens is new IITs, they try to work on the placement because they want to improve their ranking. So that is the reason it's not too bad to get into the new IIT, but yes, you have to compare with these three NITs according to the ranking. Okay, fine. Chaliye, next question on the screen. I hope so this is clear. The answer is down to 2 decimal is 1.36 meter per second square. Next question. A ball of mass 3 kg moving with a velocity of 4 meter per second undergoes a perfectly elastic direct central impact with a stationary ball of mass m. Okay, so we are having a ball which is having a mass of 3 kg, right, moving with a velocity of 4 meter per second. It is having a perfect elastic collision with the mass m initially at stationary. After the impact is over, the kinetic energy of 3 kg ball is 6 joule. What is the possible value of this mass m? Can you tell me? What could be the possible value? This is an MCQ, not an MSQ problem. Okay. What is the possible value of this mass m? And please do share, like and share this video, guys, because we are giving you the entire 1-by-1 question solution from 19 to 23. So definitely it requires one effort from your side. Okay, fine. Chaliye, quickly. Now we can directly apply the conservation of linear momentum. We can easily apply the conservation of linear momentum. Okay, so applying the conservation of linear momentum, that is m1u1 plus m2u2 is equal to m1v1 plus m2v2. Okay, fine. So this is 3 into 4 plus this is initially it was stationary. This is 3 into v1 plus m into v2. 3 unknown variables. Okay, so we can write this equation as 3v1 plus mv2 is equal to 12. Equation number 1. Now what is the next equation we can frame? We can apply the conservation of energy also, because they have given after the impact is over, the kinetic energy of the 3 kg ball is 6 joule. 6 joule energy hai iski. So we can say conservation of energy. Applying the conservation of energy, right? I can say half into m1u1 square plus half into your m2u2 square. There is no kinetic energy because in the same line of action they are having a collision. That is equal to the final kinetic energy m2v2 square plus half m1v1 square. Okay, so this is half get cancelled out. M1 is 3 into 4 square plus 0 plus m into v2 square plus this energy is already given as 6 joule. Right? Okay, so from here I can simply say that your mv2 square is equal to 16 into 3 minus 6. 16 into 3, 48, 40, that is 44. Yes. 16 into 3 minus 6, 42. Yes, are we getting this? mv square, 3 into v square. Okay. We have to have that half also, or else we won't be getting the correct answer. So this is 48, that is 30, 54. Yes. Are we getting this 36? Are we getting this 36? Right? 16, that is 3, 48, 40 divided with this is 24, 24 minus 6, that is 18, 18 to 3, 36. Yes, when this is 36. So this is equation number 2, right? So this is equation number 1, this equation, but the thing is, in equation number 1 we are having 3 unknown variables, equation number 2 we are having 2 unknown variables. So how we can proceed? Yes, what we can do is we can write instead of this one, yeah, okay, so we can say 3v1 plus mv2 is equal to 12 is equation number 1. Okay, we have to calculate the value of this one, mass m. We have to frame a quadratic equation. Yes. Okay. And one more thing, we are having a direct perfect elastic collision. Can we say E is equal to 1 is equal to V2 minus V1 divided by U1 minus U2? Okay. So V2 minus V1 is equal to U1 is equal to 4. So this is equation number 3. So let me write V1 is equal to V1 is equal to, or V2 is equal to V1 plus 4. Okay, this is equation number 3. This is equation number 1. Okay, fine. So what we can do is we can place this over here and we can frame out the equation. Let us place this value in this equation. We can get, what we can do is, we can do one thing. V1 को eliminate करते हैं. V1 is equal to V2 minus 4. Okay, placing this over here, 3 into V2 minus 4 plus m into V2 is equal to 12. So we can solve this. 3V2 minus 12 plus mV2 is equal to 12. So this will be 3 plus m into V2, 3 plus m into V2 is equal to 24, right? Okay, and we can place this m as 36 by, or we can place this V2 square is equal to 6 by root m. Okay, yes, okay. So I can say that 3 plus m into V2 ki jagah we can write it as, or let us calculate this in this way. M ki jagah we can write it as like this. M ki jagah we can write it as 36 by V2 square. Okay, or we can say this is V2 square is equal to 24 square by 3 plus m. V2 square kitna hai? That is 36 by m. 36 by m is equal to 24 square by 3 plus m, right? So this is 6, this is 4, and this get cancelled out. So ultimately we'll be framing one equation that is equal to, we can say this one square also, right? Okay, we'll be getting a quadratic equation. We'll be getting a quadratic equation that is m square plus 9 plus 6m is into 36 is equal to 24 into 24 into m. So this is 4, that is 16. So we can say m square minus 10m plus 9 equal to 0. So m square minus 9m minus m plus 9 equal to 0. So m minus 9 into m minus 1 equal to 0. So mass is equal to 9 and 1 kgs. We are getting two values, 9 and 1 kgs. So option B is the correct answer. Okay, option B is the correct. Is this clear, everyone? Yes, everyone, is this clear? 9 and 1 kgs is the final correct answer to this problem. Okay, clear? Chaliye, perfect. Next question on the screen, question number 13. Again, this is a question from, again, we have to apply the conservation and your momentum conservation and energy conservation. And a rigid block of mass m, 10 kg having velocity of 2 meter per second strikes a stationary mass of mass 30 kg after traveling 1 meter along a frictionless horizontal surface as shown in the figure, right? You have to tell me if the two masses stick together and jointly move by a distance of 0.2 meter further along the same horizontal direction, same frictionless surface, before they touch the massless buffer that is connected with a rigid vertical wall by means of linear spring, having a spring constant of 10 to the power 5, what is the maximum deflection of the spring in centimeter? That means this collectively M1 and M2 is collectively moving and hitting this spring, what is the maximum deflection happening in this spring? Very simple hai. We have to apply the concept of conservation of momentum, and we can apply the conservation of energy. Both we can apply. Conservation momentum, conservation energy. Let us first of all apply the conservation momentum, because we need to see what is the velocity with which this combined body will be hitting the surface. Okay, that we have to identify. Right. So first of all, let us apply the conservation of momentum. One second, guys. Let us apply the conservation of linear momentum. Conservation of linear momentum. Okay. So initially this at a zero velocity, so we can say m1 v naught plus m2 into 0, and they are sticking, like they are sticking together. So we can say this will be equal to m1 plus m2 into a velocity v, right? Into a velocity v. So what is the value of m1? m1 is equal to 10. 10 into v naught is 2. This is 0. This is m1 and m2. This is m1 is 10 and m2 is 30. That is 40 into v. So v is equal to 20 by 40 is 1 by 2 meter per second. Okay, that means this is the velocity with which the combined body will be hitting that particular frame, and we won't be having any decrement in the velocity because there is no friction. The same velocity it will be hitting. So now we can say conservation of energy we can apply. I can say that this entire two mass m1 and m2, they are moving with a velocity of 1 by 2 meter per second. They are hitting this particular spring, right? They are hitting this particular spring surface, right? So when they are hitting, so all the kinetic energy will be converted into a potential energy. All the kinetic energy will be converted to potential energy. So we can say the total kinetic energy will be exactly equal to the potential energy stored in the spring. Okay, so half into m1 plus m2 into v square is equal to half into k into x square. So m1 plus m2 is 40, v is 1 by 2 whole square is equal to k value is 10 to the power 5 into x square. So from here I can say x square is equal to, this is 4, that is 10, 10 divided by 10 to the power 5, this is 10 to the power minus 4, or x is equal to 10 to the power minus 2 meter. They are asking the value in centimeter, that is equal to 1 centimeter. So the maximum deflection in the spring that will be occurring will be 1 centimeter. Is this clear, everyone? Is this clear? Okay, fine, done. Chaliye, next question, question number 14 on the screen. The plane of the figure represents an horizontal plane. The thin rigid rod at rest is pivoted without friction about a fixed vertical axis passing through point O. Its mass moment of inertia is equal to 0.1 kg centimeter square about point O. A point mass of 0.001 kg hits it normally at 200 centimeter per second at the location shown, and it sticks it immediately after the impact. What will be the angular velocity of the rod? Okay, let's see who will be giving me the answer. Who will be giving me the answer to this? Simple question. There is a rod, okay, it is at rest, and there's a mass coming with a velocity of 200 centimeter per second. It is hitting. Just after hitting, what will be the angular velocity of the rod that they are asking? Okay, so can we say here we will be applying the law of conservation of linear moment, angular momentum. Angular momentum. Yes. Chalo, let's try to apply. Let's try to apply the logic over here. Now, as they are saying that this mass is sticking with this particular rod, so what is the new moment? Like, initially we are having the moment of inertia of this rod is about 0.0, that is equal to 0.1 kg meter square, right? But as they are sticking, so we'll be having a new moment of inertia, mass moment of inertia, right? So I can say the combined moment of inertia will be equal to 0.1 plus mr square, right? It's centimeter square, na? Mr square, that is equal to 0.001 into your radius is 10. Radius is 10, na? Radius is 10 square because it is sitting at a distance of this one. So solving this, it will be 100, 0.2. This is 0.2 kg centimeter square. So I got the moment of inertia of the combined body. It is sticking. Okay, so I got that value. Now we can apply the law of conservation of angular momentum. Applying the law of conservation of angular momentum. Okay, so law of conservation of angular momentum, it's basically m into v into r is equal to whatever your momentum, angular momentum that is was with this particular mass, after hitting it will be transferred, that is equal to the combined moment of inertia into omega. Yes, so what's the mass? That is 0.001, I think 0.001 into velocity is 200, radius is 10, combined moment of inertia is 0.2 into omega. So omega value, quickly, what is the value you're getting? Anyone who has tried this, solve this, tell me. What is the value of omega? Simple calculation, guys. 1 second. Okay. चलिए बताइए. What is the value of the angular velocity just after hitting the rod? Done. कितना है? देखो यार, 0.2, this will be 1, 2, 3, 1, 2, 3, this is 20. So 2 by 0.2, that is 10 radian per second. Are we getting the angular velocity as 10 radian per second? Everyone? 10 radian per second is the final correct answer. This is 10 because they're asking in integer only. So 10 radian per second is the final correct answer. Okay, fine. Chalo, question number 15 on the screen. A structure along with the loads applied on it is shown in the figure. The self weight of all the members is negligible and all points are frictionless. AE is a single member. Try to visualize. It's not a, this is a single member. AE is a single member which is and contains a pin C. Likewise, B also a single member, right? That contains point D. The member GI and FH are overlapping rigid members. The member GI and FH are overlapping rigid members. The magnitude of the force carried by CI. What is the force in the CI member? Now, let us suppose if this AE is not a single member, if I say AC and CE were different members, then CI was a zero force member. Then CI was a zero force member. But as your AC and CE is basically a single member only, that is the reason we have to, we cannot say directly that this is a zero force member. We have to do the analysis, right? So now again the truss problem, what we have to do? We got truss problem, we have to go for method of section, right? So now let us try to take the method of section, try to cut the section from here. CI we need to calculate, right? Let's cut the section from here, or else what we can cut the section from here also. Better we can cut the section from here. It will be much more easier. So if we cut the section from here, so this is eliminating the left hand side. So this is your I, this is FCI, right? This is your FIE, this is point E, right? And this is a complete member, won't be having over here. This is a complete member. Or let us do the, okay, this is over here. Let us cut a section like this. So we can say this is I, this is FCI, right? IE is a complete member. This is a complete member. This is FDE, right? And this is FCE. I need to calculate CI. So if we want to calculate the value of CI, can we say that we can directly take the moment about point E? We can directly take the moment about point E, and definitely we need to draw the rest of the diagram. I'm not drawing the entire diagram, right? I'm not drawing the entire diagram, just only that applied load I need to show. This is H. Okay, this is H having a force of 2, and this is G having a force of 4. right? So if you take moment about point E and make it equal to 0, moment about point E, make it equal to, this is your point E. This is your point E that we are having. Okay, fine. So I can say that FCI. Now, if you see this triangle, if you see this particular triangle, right, as this height is 3, this is 2, this is 2, that means I can say this is equal to 1.5. If you see this triangle, similar triangle, I can say the smaller triangle is the bigger triangle, the height AB is 3 meter, CD will be equal to 1.5. So FCI into 1.5, this is in the anti-clockwise direction, plus 2 into 1.5 clockwise direction, plus 4 into till this point 3 plus 3 is 6 equal to 0, right? So solving this, FCI is equal to, this is 24 plus 3, 27, 27 divided by 1.5, so that is equal to 9 by 0.5, that is, I can say 9 by 0.5 is 18. Are you getting 18 kilonewton? 18 kilonewton. Okay, 90 divided by 5 is 118. 18 kilonewton. So the answer for this is 18 kilonewton is a correct answer. 18 kilonewton is a correct answer. Clear hai? Okay. Chaliye, perfect. Perfect. Question number 16 on the screen. Two rigid massless rod PR and RQ are joined at the frictionless point. So I can say pin at R. So R is a frictionless pin joint resting on P and Q respectively, as shown in the figure. The vertical force acts on the pin as shown in the figure. When that included angle is less than 90, the rod remains in static equilibrium due to Coulomb's friction between the rods and the ground at location P and Q. When this theta is equal to 90, we are having an impending slip. That means we are having an impending motion. That means about to occur. The motion is about to occur, right? You have to tell me what is the ratio of friction at point Q to that of P. That means mu Q divided by mu P. This ratio you have to calculate till 2 decimals. Till 2 decimals. Easy question. Hai. Try this. Easy question quickly and do let me know what is the correct answer. Do let me know what is the correct answer. Easy question. Now, as this is 90 degrees, so let us draw the diagram. That will be much more easier for us. Okay. So we are having this as point R. This is point R. This is point P. Right. This is your point Q. This is point Q. Okay. This is F, force acting. Okay. This is 90 degree. Right. So once you are going for, let us try to take the free body diagram of joint P. Okay. If I draw the FBD of point P, I can see that there will be a friction force acting on the left hand side. This is point P only. There is a normal reaction acting, right? Okay. Fine. Yes. So something like this. If I draw it like this, this is the frictional force. And this is the normal reaction, and this will be the force in the member FPR, right? Now, when this is 90 degree, it is clearly stated that this is having an impending slip, that means the body is still in equilibrium. So can I say the resultant of these two forces will be acting in the exact same line of action of that of PR? If I say the body is not moving, it's a static equilibrium, that means the resultant of these two, that means the normal reaction and the friction force, that is, this is R, that will be making the same line of action as that of PR, right? And what is the angle made by PR? Let us suppose this angle is alpha. So can I say this is alpha, right? If this is alpha, this is also, but this is 90 minus alpha. This is 90 minus alpha. Okay, now you can apply the concept where alpha is the angle of friction at point P. So I can see your tan alpha or tan 90 minus alpha is equal to mu P. Can we say? By tan phi is equal to the coefficient of friction. So can I say the angle between the result and the normal reaction is the angle of friction? Over here it is 90 minus phi. So can I say this is cot alpha is equal to mu p. Let us say this is equation number 1, right? Okay. Similarly, can we go for point Q? Now, point Q force being applied, so friction force will be in this direction. Okay. So, if I take a free body diagram of point Q, so we are applying a force, the body try to move right side, the friction will be on the left hand side. This is your point Q. This is your frictional force acting. This is the normal reaction, right? And there's a force FRQ in this direction. This is FRQ. FRQ. So the resultant will be in the same line of action of that of this, right? And this angle, let us suppose this is beta, right? So this angle is beta. So this is 90 minus beta. So over here I can say tan of 90 minus beta is equal to mu q. That is cot beta is equal to mu q, right? So if I manage to calculate the value of cos alpha, cot alpha and cot beta, I'll be getting the value of this ratio. Now, looking at this equation, we can say if this is alpha, what is tan alpha? Tan alpha is equal to 12 by 5. If I say this angle is beta, because this is 90 degree, I can say tan beta is equal to 5 by 12, right? So let us place it over here. We need to calculate the ratio of mu q by mu p. Mu q by mu p is equal to cot beta by cot alpha, that is tan alpha by tan beta, right? What is tan alpha? Tan alpha is 12 by 5. Tan beta is 5 by 12. Okay, so this is 144 by 20. Okay, 144 by 25. So mu q by mu p value is 144 by 25. What's the value we're getting? 144 divided by 25, 5.76. 5.76 up to 2 decimals we are getting. So 5.76 the final correct answer to this problem. 5.76. Clear? 5.76 is the final correct answer. Okay, 16 question done. So shall we proceed to the next problem? Yes. Correct? Chalo, let's proceed. Question number 17. Only 5 more questions being left out. A cylindrical disc of mass 1 kg and radius 0.15 was spinning at omega of. This is a very interesting question. I think GATE 2022. This question was asked in GATE 2022. Okay, was spinning. There was a disc which was initially rotating at 5 radians per second, and when it is placed on a horizontal surface and it is released, that means initially it was rotating. It was not with the contact with the surface. Rotating with the 5 radians per second. With that rotation, it is just placed. Now, gravity G acts vertically downward as shown in the figure. The coefficient of friction between the disc and the surface is finite and positive, disregarding any dissipation except that due to friction between the disc and the surface. What is the horizontal velocity of the center of the disc when it starts rolling without slipping? Very simple question. Simple question है. We have to apply the conservation of angular momentum. देखो actually क्या है? If I try to make you understand. Actually, when it was rolling, okay, let me draw one diagram. Let's say this is the horizontal surface. Okay, it was rolling with an angular velocity of 5 radians per second. It has placed at this moment. Let's say this is the point at which I am placing. Right. So after some, it will be moving ahead and will be having some slipping. So after some point of time, it will be having a no slip condition. At this point, let's say this is point A. Right, this is an angular velocity of how much? I think omega, that is equal to 5 radians per second. At this point, we will be having omega of, let's say, which we need to calculate. Okay, we need to calculate the velocity. We don't need to calculate the angular velocity. We need to calculate the linear velocity. Easier. So can we say, if I apply the law of conservation of angular momentum, law of conservation of angular momentum, the initial moment of inertia into omega, let's say this is I1 into, let's say this is about O, this is omega O, let us say this is O, right, should be equal to the final moment of inertia plus the mv into radius r, right? So initial is, this is a disk, okay, this is a disk, that is mr square by 2, mr square by 2, omega naught is 5 is equal to, final will be mr square by 2 into omega 2 plus m into this is omega 2 r square, mr square into omega 2. So this is 3mr square by 2 into omega 2. This is mr square by 2 into 5. Solving this, we'll be getting the value of this get cancelled out. This entire thing get cancelled out. So omega 2 is equal to 2.5 radian per second. So omega 2 is equal to 2.5 radian per second. I need to calculate the value of linear velocity. So linear velocity is equal to v is equal to r into omega. Radius is how much? 0.15 into omega is 2.5. Solve it and tell me what is the value you're getting. 5 by 3 or 5 by 2? Check करते हैं. Oh, 5 by 3, not 2.5. This is 5 by 3. 5 by 3, है ना? Right. So 5 by 3. 5 by 3. This is 0.05. This is 0.25 meter per second. 0.25 meter per second. So the final correct answer is 0.5. And if you try to see, majority of the questions in the engineering mechanics, they are NAT problem. Okay, NAT based problem में ही आपके क्वेश्चन ज्यादातर पूछे जाते हैं मैकेनिक्स सब्जेक्ट से. चलिए next question is slightly interesting. A square plate is supported in 4 different ways. It's an MSQ problem from the mechanics. MSQ problem 2022 में पूछा था, I think 22 या 23 में. As shown in the figure, a couple moment C is applied on the plate. Assume all the members to be rigid and massless and all joined to be frictionless. All supports of the plates are identical. Then you have to tell me which of the following configuration is an equilibrium condition. Okay, so let us take one by one. This is P. Now, if you try to draw the forces, this is a square. Okay, this is a reaction R, reaction R, reaction R. So definitely they are passing equal forces having 120 degrees. So definitely the total force will be equal to 0, but there is no force which will be trying to, there is no moment being created. So the system is, because this couple will be trying to rotate, it's an unbalance. So this is not an equilibrium, not in equilibrium. It's very easy. At the 3 points, the reactions will be acting, equal reaction will be acting, and definitely the total force will be equal to 0, but there is no one to create, to nullify this couple, the applied moment. Okay, the couple moment that is being applied in clockwise direction. So this is not in equilibrium. So this is not in equilibrium. Let us go with configuration Q. Now configuration Q, if you try to see, there's a force acting. If I try to draw the FBD, so we're having a force like this, R, 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 and R. Okay. So net horizontal force equal net vertical force, perfect. The net force is equal to 0. Right. And also if you see, this reactions will create a counterclockwise movement. This will create a counterclockwise movement, and applied couple is clockwise. So this will be nullified. So this system is an equilibrium condition. This system is an equilibrium condition. So Q is an equilibrium. Option B is correct. Let's go with the configuration R. Now if you see configuration R, equal and opposite force will be acting. Okay, we'll be having a force R and R acting, and this 2R will create a counterclockwise movement which will be nullifying the clockwise movement. Again, this is an equilibrium. Again, this is an equilibrium condition. So this is also correct. Let's go with the last one, configuration S. Now if you see the 2 forces acting, so can we say, if I assume this force acting like this, so the other force will be acting in the anti-clockwise direction like this. Okay, fine. Basically, if you try to visualize, one force will be upward and other force will be downward. So I can say that this is clockwise. So we have to create an anti-clockwise. This is your R. This is your R. Right. So net force equal to 0, and these two reaction force will create an anti-clockwise movement clockwise couple will be nullified. So this is also an equilibrium condition. Okay, so I can simply say all these three options B, C, D is the correct answer. B, C and D, all these three are the correct answer. Clear hai? Fine, understood. Chaliye, next question on the screen is from the topic again, very easy question. Quickly, a rope with two massless platform at its two ends passes over a fixed pulley as shown in the figure. The disc with nano slots and having equal weights of 20 Newton. That means we are having a disc, okay, which is having a weight of 20 Newton each. The number of discs placed on the left hand side platform is N and the right hand side is M. Right. It is found that for N equal to 5 and M equal to 0, a force of 200 Newton we need to apply in order to initiate the upward motion on the left side of platform. If F is being removed, then what is the minimum value of M for refer the part figure 2, this is the figure number 2. Okay, this is figure number 2, this is figure number 1. Prevent the downward motion on the left hand side platform. Okay, very easy, very easy. Chalo. Now, if you try to visualize, if I try to draw the first diagram, the first one, first case, this is your first case, right? So we are having a force of, now how many plates are there? 5 plates, each is having a weight of 20 Newton. So it will be 100 Newton. This is 100 Newton weight, right? Okay, and we are having a net force acting, that is 200 Newton being applied. This is 200 Newton, 200 Newton. So definitely this is an example, this is not an example of pulley, this is an example of a belt drive. Let's say this is T1, okay, this is T1, yes, already this is, right, and this is T2. So the angle of contact will be exactly 180, this is 180 degree, right? So can we say that T2 by T1 is equal to e to the power mu into theta? T2 is 200, T1 is 100, e to the power mu value we need to calculate, theta is 180, that is pi. Solving this, let us calculate the value of the coefficient of friction. Let's calculate, this is, yes, 2, ln2 divided by pi. This is 0.22. 0.22 is the coefficient of friction. Now consider the second case. In second case, what we are doing, we are removing this 200 Newton force. We are not applying 200 force, we are applying M disc. So we need to see how much M disc we need to apply. Okay. So same problem. Now the same disc, that means 100 Newton is still present. Now there's a force, let us say T3 being applied, and definitely this will be having a 180 degree of angle of contact. So I can say this is T1, right? T1. Okay. So how much we need to apply in order to have this to be down motion on the left hand side platform? Okay, down motion on the left hand side platform. Chaliye bataiye. So I can simply say that T3 by T1 is equal to e to the power mu into pi. T3 we need to calculate. T1 value is okay. We have to go downward on the left hand side, right? So that means your T100 will be moved. So this is 100 by T3 is equal to e to the power mu into pi. So T3 will be equal to 100 divided by e to the power 0.22 into pi. So solve it and tell me what's the value you are getting. E to the power 0.22 into pi 100 0.22 into pi 100 divided by answer, that is 5. T3 is equal to 50 Newton. Exactly, we are getting 50 Newton. That means on this T3 we are stacking M disc. We are stacking M disc, right? And each disc having a weight of 20 Newton. So there are M disc being stacked, which is having a total weight of 50 Newton. Each disc having 20 Newton. So number of M disc will be equal to 50 divided by 20, that is 2.5. Practically it's not possible to have a decimal, so we can go for the next integer, that is 3. So the final answer is 3. Final answer is 3. Okay, right? Because why we have to say we have taken this left hand side, we have to move downward. In the previous case, initiate the upward motion of the left hand side. Okay, left side upward motion means this is a slack slide, this is tight side. Left side downward motion, this is the tight side, this is slack slide. Okay, so from this I am getting number of MDIS is equal to 3, a simple question from the concept of the belt frame. Okay, 20th question on the screen. A rigid homogeneous uniform block of mass m, 1 kg, height h equal to 0.4 meter, width of b is equal to 0.3 is pinned at one of the corner and placed upright in a uniform gravitational field supported by a roller support configuration. A short duration of impulsive force. So basically we are having, it's something like this. We are applying a very small amount of impulsive force like this. Okay, so due to this very small impulsive force, it will be having some tilting motion. So they are saying that what should be the minimum value of this impulse required to topple the block. That means how much minimum impulse force we need to apply so that it is just on the verge of toppling down. Okay, that we need to calculate. Fine, that we need to calculate. Okay, so what we can do is, this is your, let me draw the diagram. Better I can draw the diagram, that will be much more easier for you guys. Or let me do one thing. This is the center of gravity. Okay. Okay, chalo, let's do one thing. Let us draw it over here. So we are having initially it was placed over here, right? It was placed over here. This was a hinge point, and there was a roller support being placed. Okay, there was a roller support, something like this. Okay, let's say this is the G point, and there's a force being applied exactly at point over here, right? So this is, so just after applying, let me draw it over here because I need to draw the diagram. This is the hinge point, right? This is that, we can say something like this. This is that hinge point. Okay, now what we can do is we can draw the center of gravity over here, right? Let's say this is the center of gravity. This is your weight W. This is the force F acting. The force. There's a very interesting question asked from the impulse momentum, impulse force concept. Okay, so just we are applying the force so that it is just sufficient enough to topple down. Okay, so can I say that when you are applying this impulse force, it will be having a configuration such that its G value has been shifted, or it is being moved a bit ahead like this. Okay, this is your new position, right? This is your weight W acting exactly from here. Fine. What are the dimensions that we are having? The height is 0.4 and width is 0.3. 0.4 and 0.3. This is 0.3. This is 0.4. 0.4. Height is 0.4, right? Okay, so can I say when it has shifted to this point, can we calculate this new height h dash? Can we calculate this new height h dash? Yes or no? So if you try to visualize, this is the center point, right? So this will be half, that is 0.15. This distance will be 0.15 and this height will be 0.2. So from here, let's say this is 0.0, I can say OG dash, let's say this is G dash. OG dash is equal to root of 0.2 square plus 0.15 square. Let's try to solve it and just see what is the value we're getting. 0.2 square plus 0.15 square, root of this 0.25. 0.25, I think all the dimensions are in meter only, 0.25 meter. Okay, so the total height is 0.25 meter. Okay, so can we get the value of h dash? Can we get the value of h dash? Can we say h dash will be equal to, this total height is 0.2, so h dash will be equal to OG dash minus 0.2. So this is 0.25 minus 0.2, that is 0.05 meter. That means it is the center of gravity is being lifted by a height of 0.05 meter. So now let us apply the concept of energy balance. Okay, now let us apply the energy balance. So if you apply, we are applying some energy, right? So that energy is being converted, the rotation kinetic energy is being converted into the potential energy, right? So I can say half into I0 into omega square, that is initial value, because at this point I am giving some angular velocity. At this point it is tending, that means your omega is equal to 0. At this point it is like this. I am applying an impulse force and it is just stationary, just about to top of them. At this point, when the center of gravity does that, the weight is passing through the hinge point, is at that point your omega is 0. If you are applying slight more value, it will be topping down. So we are talking about on the verge condition. Okay, fine. So from here I can say that is equal to m into g into h dash. Yes, fine. So what is this one? I naught we need to calculate. So if I talk about I naught will be equal to, this is a rectangle, right? We need to calculate the moment of inertia. Let me use this side. This is 0. So what is the moment of inertia at this point? From one of the edges. Okay, that will be equal to 1 by 3 height square plus breadth square. So this is 1 by 3, height is how much? 0.4 square, breadth is 0.3 square. Let us solve it. What's the value of I naught we are getting? 4 1 by 4, that is 1 by 12. So I naught value we are getting it as 1 by 12 kg meter. This will be this one, kg meter square. Okay. So placing this value over here, placing this value of I naught over here, and initial angular velocity we can easily identify. Right? Is this clear? So we can say this is 1 by 12, right? So half into 1 by 12 into omega's initial square is equal to m. What's the mass of this block? Mass is 1 kg. 1 into 9.8, I think 9.81 into h dash is 0.05. So the initial value of the angular velocity is equal to, let us calculate the direct value. It is equal to 3.43 radian per second. Okay. Now we can say the angular impulse. Angular impulse is equal to the change in angular momentum. The change in angular momentum. Okay. So the impulse into, we are applying at a height of d. We are applying at a height of 0.3. Okay, we are applying a height of 0.3. 0.3 is equal to change in momentum is I naught into initial momentum, initial angular velocity, the final angular velocity. This is equal to 0. 1 by 12 omega is 3.43 minus 0, right? This is IF into 0.3. So from here, IF is coming out to be 3.43 divided by 12 into 0.3. What is the value you are getting? Quickly. 3.43 divided by 12 divided by 3. So 0.09527. Okay. Yes. Oh, not 0.0, 0.9. 0.9527. 0.9527 Newton meter is the answer that we are. We having any option over here? Yes, option A. 0.953. 0.953 Newton meter is the final correct answer. Okay, option A is the correct answer. Clear? Done. Next question, 21st question on the screen. A spherical ball weighing 2 kg is dropped from a height of 4.9 meter onto an immovable rigid block. That means that rigid block is not moving. Okay, if the collision is perfectly elastic, what is the momentum vector of the ball in kg per second just after the impact? Take the acceleration due to gravity as 9.8 meter per second square. Options has to be round off to 1 decimal. Okay, so very easy question. So it's basically we are having a mass, right, it is falling. So first of all, let us calculate what with which velocity it will be hitting that particular rigid block. Okay, fine, it is being dropped, so initial velocity equal to 0, so it will be, let us suppose it is hitting the block with a velocity of u. It is hitting the block with a velocity of u, right? So I can say we can take it as 2 v square is equal to u square plus 2as, simple. Okay, so u is equal to under root of 2 into g into h, so 2 into 9.8 into 4.9, root of this will be 9.8 meter per second. That means this 2 kg spherical ball is hitting the rigid block with a velocity of 9.8 meter per second. Okay, so what we have to do is, let us try to draw the line of impact. Let us suppose this is the line of impact. Okay, this is your angle 30 degree, right? So if it is hitting, so definitely after the collision, it will be moving, let us suppose with a velocity of v. I don't know where it will be moving. Let's say it is making an angle of theta, right? But the one thing they have given that it is a perfectly elastic. It's a perfectly elastic collision. That means if I take along the line of impact, this is your line of impact. This is your line of impact, right? So if I try to apply along the line of impact, along the line of impact, can we say u cos 30 degree will be exactly equal to v cos theta along the line of impact, and perpendicular to line of impact, can we say u sin 30 is equal to v sin theta? So solving equation 1 and equation 2, we are getting, because u is equal to 9.81, so u is equal to v is equal to 9.8 meter per second. We got the final velocity. So now we can say the momentum, okay, the momentum after the impact, right, that will be equal to m into v into what is this complete angle? This is and this is equal to 30, right? If I calculate, this theta is coming out to be 30 degree only, right? So I can say v cos along the, this is your y direction, this is your x direction, or I cap and j cap. So we can say this is v sin 60, and in this direction we'll be having v cos 60, right? So I can say that it will be mv into sin 60 I cap plus mv cos 60 j cap. Okay, fine. So what's the mass? Mass is, I think, 2 kg. Mass is 2 kg. 2 into velocity is 9.8. Sin 60 is root 3 by 2 I cap plus 2 into 9.8. 2 into 9.8 cos 6. This is 1 by 2 j cap. So this is 9.8 into root 3. 16.97 I cap plus 9.8 j cap. So we can say this is round off to 79 cap plus 9.8 j cap. Okay, so the correct answer is option C is the correct answer, right? Option C is the final correct answer. Clear hai? Done. Chaliye, last question. From the concept of the moment of inertia, area moment of inertia, we need to calculate for this linear tapered section. We have solved this type of question in our paid courses also, number of times, many type of questions. So what we can do is, let us try to, because this is symmetrical about the x-axis, so I can say that this is basically a combination of a rectangle. Okay, this is a combination of a rectangle and a triangle. Let's say this is point O, this is A, this is B, this is C, this is D. So if I try to remove from the rectangle this triangular portion, I'll be getting the half moment of inertia multiplied by 2 will be the complete moment of inertia of this tapered section. Okay, so what is this height? This is 3 meter. This height is this height is 1.5 meter. This is also 1.5. The total is 3, and this width is 12 meter. So first of all, let us calculate the moment of inertia. The moment of inertia of the rectangle about, and we need to calculate about which, about the y-axis. That means about this point. That means about y-axis. Okay, about y-axis, that is along OC. Along OC, right? So that will be equal to 1 by, because this is, we are talking about this axis. Okay, so that will be equal to 1 by 3 BD cube. 1 by 3 BD cube. So that will be 1 by 3 into 3 is the depth, breadth is 12, so 12 cube. So this is 12 cube, meter 4. And the moment of inertia of the triangle about y-axis, that is along OC or CD, that is equal to your 1 by 12 into base is 1.5 into cube, the height cube is 12 cube. Okay, fine. So this is coming out to 1.5 by 12 is this is 5. Okay, so this will be 4, 3, 2, 8 by 8, 1 by 8, 1 by 8, 12 cube. Okay, so we have calculated for the half portion, the rectangle and the triangle. So the moment of inertia of the shape OABD is equal to the moment of inertia of the rectangle minus moment of inertia of the triangle, that is 12 cube minus 1 by 8 into 12 cube, that is equal to 7 by 8 into 12 cube, right? This is only for the half portion. If I want to go the complete whole section, the moment of inertia of whole section will be equal to 2 into 7 by 8 into 12 cube. So this is 7 by 4 into 12 cube. So what is the value that we are having? 12 to the power 3 into 7 divided by 4. So this is 3024 meter to the power 4. So this is the moment, area moment of inertia, that is 3024 meter to the power 4. Okay, so these are all the questions. Near about, we have taken 1 hour 44 minutes to cover up from 2019 to 2023. Okay, so make sure you are all watching this session in the recorded also. If you are watching, it's good, and you have got all the solutions from 19 to 2023, and there is a link in the description box about the GATE workshop which Rakesh sir will be taking, and also the link for the GATE scholarship test. Up to 90% will be getting the scholarship, that is ratio you can say. And also we always give you the free resources. You can download the free ebooks. The description is in the comment section. Fine, clear? And this is my Telegram channel. I'll be sharing the PDF of this session in the Telegram channel. Make sure you all are downloading it. That's it from my side. This is Suraj Gopi signing off. I hope you all enjoyed. Thank you. Stay safe, stay connected. We'll meet in the next session with more such energies. Thank you guys. Bye bye. Take care. Stay safe.